Our first speaker is a colleague of mine, Professor Benjamin Dillenburger at ETH Zurich. And Juliana, if you could stop sharing, and Benjamin, you can start to share your screen. And Benjamin is an assistant professor or associate professor in digital building technologies in the Institute of Technology and Architecture. He's been working on several very exciting projects, and I asked if he would share a little bit about what he's working on now. So Benjamin, with that, please feel free. It looks like we can see your screen, and I don't see your video yet, but go ahead and turn on your video, and we look forward to hearing from you.
Okay, thank you very much, Daniel, for the kind introduction, for giving me the opportunity to speak in this very interesting context of mine. I tried to turn on my video, but okay, now I have the rights. I think I was too early with turning on the video. Okay, I hope the connection is well. I will directly dive into my topic because I have a lot to tell. So my research topic is, and the talk I will hold now is about additive construction. I will quickly go through what drives us, our research. I will focus on the additive manufacturing of slabs, so it fits very well to the previous talk, and give an outlook of our research. And especially now looking at the concrete construction industry, I think it's time that we change the way we build. If we compare images of construction sites, which are almost 70 years apart, we don't see so much development yet. So there's a huge potential of digitization and modernization of construction. Our goals are to dematerialize architecture using less material, saving and reducing embodied energy, to increase also the performance of building elements, to make them more affordable by improving the productivity of the construction process, but also to allow a higher diversity in architecture without creating extra costs. The research focus of my group is large-scale additive manufacturing. How can we use that in architecture? Related computational design, and we focus on element-oriented design, meaning we also have a strong focus on prefabrication still. So one of our visions is really a continuous digital process chain, meaning that all the design parameters are in the computer already, would be sent to a fully automated production line, and then deliver high quality building components, which are then assembled on the construction site. And one key focus of our group is slab constructions. And why slab constructions? They represent a large amount of mass and weight in concrete buildings. So if you want to reduce the weight, then this is a good place to start with. They are central carriers of media and infrastructure in buildings, but also they are one of the largest visible surfaces in modern skeleton constructions. And we not only focus on reducing the cost, but also think of how can we increase the value of these elements by adding and integrating more functionality. So for example, in the project Smart Slab, and this was a concept, early concept diagram, we try to bring in as much functional layers into one prefabricated building element as possible. For example, including thermal activation, acoustic performance, lighting details. So the construction site itself becomes very simple and needs less time. And one strategy we are following is to 3D print formwork for concrete. Why at all using 3D printing in construction? I guess this is the topic of the session today anyway. First, we should consider every house as a prototype. At least the context of every house will be individual. Building parts are generally used in small lot sizes. And whenever we try to optimize geometry or elements, that leads to a complex geometry that is then more difficult to fabricate with traditional means. And last but not least, we want to avoid create a larger design freedom. We work a lot with one of the largest high-resolution 3D printers in the world, a binder jet printer. What is special about this binder jet printer that it can print 4 by 2 by 1 meter parts from sandstone with a incredible high resolution. So roughly 10 or 20 times in each dimensions bigger than the screen you are now looking at. So all this information can be imprinted in building elements without any impact on the construction time of the element. And why using it for formwork? Because formwork represents the largest amount of labor in concrete construction. Especially when we are talking about optimized geometries, formwork is actually one of the biggest cost factors, also the challenge to at all create some of the parts. So here you see a geometry now of an optimized slab element, a prototype, 2 by 1 meter tall, which we optimized with a topology optimization to reduce and take away the material that is not needed. And usually that would pose a huge challenge to the construction, but we use this 3D printer or the smaller version of it to print a stay-in-place formwork within roughly 45 minutes to 1 hour to then be able to cast a fiber-reinforced concrete inside. So with this design, we were able to save up to 80% of material. And also, as you can see, the hollow part of this incredible filigree concrete structure allows also the integration of installation and media. This led to a larger research project, the Smart Slab in the DFAB house, where we use another strategy to save material, pre-stressing, as you can see in this toy model. So the construction principle is to create prefabricated slab elements, which are then assembled on site and pre-stressed to gain the full structural strength. And I want to highlight here that we use the 3D printed formwork to basically encapsulate all the complexity that is required for example, aligning all the ingredients that we need in concrete construction in a very high precision. So also here we reached for 7 meter long concrete elements, a precision that is in the range of 1 millimeter. And we had to, because we also reduced the dimension of this concrete part to really minimum that is required. So you see here 10 centimeter ribs, for example, with exactly 20 millimeter cover of the rebar that are integrated. So the construction assembly on site is then very fast and very precise. So all the post-tensioning cables had to fit between these elements. So it's extremely important to be that precise. And we could, with this optimized design, reduce again over 60% of concrete material. Here I just show pictures of the construction site. So one, besides all the different aspects that we learned from this project, is that we are also facing here a very new technology, which is fast developing. And while we developed this project, for example, the printing technology, binary printing, became again 4 times faster with new material combinations. So looking at the role of 3D printing, one can always consider that also these production technologies are extremely dynamically developing. A follow-up project of this, because you could see in this design, the upper part of the formwork was still created with CNC milling and with manual labor involved. We created a process that combines 3D printed formwork to create a high detailed surface on the lower side of the part with directly 3D printing. So in this project, as you can see here, we 3D print on a high resolution formwork in order to have a totally automated fabrication process. So here we use a mix between spraying and concrete printing to lay out a thin shell of concrete on the formwork surface and also build up the ribs. If you look at the video here of the construction, you see this buildup of the layers. And then currently in a manual process integrating of reinforcement. In this case, it's a carbon fiber mesh, and laying in the hollow tubes for the pre-stressing to connect these elements. You see here a small element, but this process would be scalable to also these 7 meter long slab elements that I showed in the Smart Slab process. And here a result of the post-tension system. Last but not least, I wanted to highlight another development of a digitally fabricated floor system. In this case, trying to avoid a conventional rebar system at all, with a geometric optimization done by the Block Research Group and an optimized building systems integration developed by Architecture and Buildings Systems Group, and our fabrication methods of 3D printed formwork. So this was a prototype of an optimized slab system shown at the World Economic Forum in Davos 2 years ago. The fabrication system is a combination, a hybridization of a manufacturing process with 3D printed formwork, and wire cut foam blocks incorporated into construction. What is specific here is that we are talking about a 20 millimeter thick concrete shell, can be even a recycled concrete because it's not very demanding in terms of strength. So, and which integrates this optimized building system. And right now, the full-scale slab construction, this was a prototype, is installed. I hope I can present this project then next time. What is next? We are intensely working on new materials for 3D printing, for example, sustainable materials that use far less cement concrete. And to summarize, I showed now 4 different projects, all addressing the same topic, slab design. And I think we are looking forward to a future where we can create more performative building elements, but also with a higher aesthetic value. Thank you very much.